So what is the real beef about meat?
What should we eat to stay healthy, and how should that food be produced so we don't ruin the planet for ourselves and future generations?
The pressures of world population growth, combined with an increased preference for Western diets, have resulted in greater focus on food production and more widespread interest in how the food we eat is produced. We're going to need more food. Society faces challenges of how best we're going to achieve this to feed more than 9 billion people by 2050. Is there a role for livestock which can compete for human food? These issues are being tested here on the Northwick Farm platform at Rothamsted Research in Devon, funded by the BBSRC and built in 2010. Alternative approaches of beef and lamb production from grassland and grazing systems are being examined. Grazing system comparisons are being performed on permanent pasture with productivity driven by inorganic fertiliser application, mixed grass-clover systems, productivity driven by the ability of clover to fix atmospheric nitrogen, reducing the need for inorganic fertiliser, and novel grass varieties, productivity driven by the potential of plant characteristics to improve the efficiency of grazing livestock.
Plants take in carbon dioxide from the air. Carbon dioxide is a harmful greenhouse gas. The carbon becomes part of the plant. When the plant dies, the carbon is added to the soil, or if the plant is eaten by cattle, some of the carbon is returned to the soil as dung. Grassland soils can hold large amounts of carbon, which could easily be lost and returned to the air as carbon dioxide if the soil is disturbed. In the lab, we compare soils from the farm to understand how management affects carbon content. Soil also contains other vital nutrients for plant and animal growth, including nitrogen and phosphorus. We measure the amount of these nutrients that exist in the soil already, so that we know how much should be added as fertiliser. Back in the lab, we also measure the quality and quantity of plant material grown to find out how nutritious it is for the cattle.
Producing meat sustainably from grassland is all about nutrients. The inputs into the farm, the cycling of them within the farm, and also the different ways in which they can leave the farm. Nutrients enter the grassland farm from the atmosphere, and we can add them in the form of fertilisers to increase grass growth, so we can feed more animals from the same amount of land. The livestock, cattle and sheep, graze the fields, grow, and some of those nutrients leave the farm in the meat of the animals for human food. But some of those nutrients are lost in other ways, which can be both financial loss to the farmer and cause environmental problems. The farm platform allows us to compare different approaches to grassland farming by measuring all the inputs and outputs of nutrients from the system, and will ultimately help us understand how to improve the sustainability of meat production. One way nutrients can leave the farm is through water. Water enters the system through rainfall, landing on the ground, interacting with the soil, and passing nutrients to streams, to rivers, and to lakes, where they can cause environmental problems such as eutrophication. Eutrophication is the growth of plants and algae in the water as a result of all these extra nutrients. As they grow, they block out all the light, and as they decay, bacteria feed on them and use up all of the oxygen. All of the water coming off the farm platform is channeled through drainage systems to flumes, where we can measure the quantity leaving the land. Some is also pumped to sensors, where we can measure the concentration of some of the key nutrients: nitrogen in the form of nitrate and ammonium, phosphorus and carbon. Another way nutrients can leave the farm is in the air in the form of gases, and these can be harmful greenhouse gases. Two important gases we lose from agriculture are methane, which contains carbon, and nitrous oxide, which contains nitrogen, and these both contribute to climate change. On the farm platform, we can measure the losses of these gases from the farm. Here we're measuring the losses of nitrous oxide. Nitrous oxide is produced when dung and urine are deposited on the field, and also following the addition of artificial fertilisers. Methane is produced from the fermentation process going on inside the animals, and also from the way we manage our manures. Methane is 20 times more potent a greenhouse gas as carbon dioxide, and nitrous oxide is 300 times more potent a gas. So it's critically important that we come up with ways of minimising the losses from agriculture.
Red meat is an important source of minerals and vitamins, such as B12 and iron. It's also a low-fat food, less than 5% fat. In addition, animals that are finished off grass and pasture have higher levels of beneficial polyunsaturated fatty acids, omega-3, compared to animals that have been finished off cereals and grains. Cattle and sheep have a special ecological niche as efficient digesters of fibre and therefore can convert land not suitable for crop production into a vital source of highly nutritious human food. Whilst ruminants are less efficient converters of total feed to animal product compared to pigs and poultry, they are not limited to using human edible feed to produce. So when looking at the conversion of human edible feeds into meat, ruminants can be as efficient as pigs and poultry and reduce the competition for cereals and grains. Beef will play a vital role in global food security if it is raised and consumed responsibly. Research at Northwick will contribute significant knowledge and innovation towards achieving future food security. We look forward to seeing you at the Royal Society Summer Exhibition.